I start the OBS recording. The Teams has recorded and written everything that told you. So this morning we did some orthonormal transformation. We will finish it and then we will switch to the eigenvalues. And I'm not really contented about the eigenvalues, how it is explained. But we will see. Yes. You should have come to my Hungarian lecture. That was funny. I got a new board, it's independent lead from this one, and when I start to use it, collapsed. So it's I ruined everything. When I tried to fix it, then I recognized that I cannot erase the text. So that was funny, very funny, at least for students. Yeah, you cannot see what I see here. So what we will do, that's orthonormal transformation. This is the third exercise from the test. So let's see the following basis. Okay, these are very nice vectors. So first, let's give an orthogonal basis of key. Let's start with A1, it's B1, it's so the A1 it's very simple. The rank of this vector is just square 2 because you know it's 1 square root 2, 1 square plus 1 square plus 0 plus 0. So this is the first basis. Do you understand? Okay, you understand. It's you should know how to calculate the length of the vector. Okay. Then the next one okay, so here there are a lot of interesting things, but the most important, I do the scalar multiplication, scalar product. 0 product 1, 0 times 1, 0 times 1, 1 times 0, 0 times 0, that's 0. So this full term, this is 0, because scalar is 0. So it means this vector is the v2 vector. So the length of this is 1. Okay, so this is the second basis vector. It's quite simple. Without zeros, it will be a longer task. So the last one okay, so this is the last one. B3. and then A2. Okay, let's see the first. Okay. Not bad. This is minus. This is this is minus 1 times 1, that's minus 1. This is 0, this is 0, this is 0, so this is minus 1. And the vector is 1, 1, 0, 0. Okay, and then 0, 0, 0, 0, 0, 0, so that's 0. This is nothing. So this is minus 1. This is the first. Minus, minus, plus. Okay, so this is the A3, comma. So I need the normal vector. these are the results. Three basis vectors. And just a quick check. We can do the scalar product from A1 and A2. Oh, where is A2? Yeah, there, okay. So A1, A2, it's 0, 0, 0, 0, 0, 0, 0. So it will be 0. So the scalar product of A1, A2 is 0. A1, A3. 1 minus 1 is minus 1 plus 1 and then 0, 0, so it's 0. So it's also the scalar product of the E1 and E3 is 0. Let's see A3, A2, A3. It's 0, 0, 1, 0 multiplied by minus 1, 1, 0, 2. Okay, it means 0, 0. Everything is 0 again. So these are orthogonal, or if you like, they are perpendicular. So this is good. These are good bases. Okay. So we can switch. Switch to eigenvalues. Problem is that is written here is very confusing.
Excuse me, Professor.
Yeah.
It's 1 over root what?
It's where? Here?
No, no. The 1 over root.
1?
Yeah, well, what's the...
It's 6.
6.
Sorry, 6. 6. It's the length of the vector. Its length is unit, so it's 1. This won't be in the test. This will be important later in your career. So I mean in physics, chemistry. I don't know how and the IT student will use it. But okay. Well. Okay, let's do something else. Let's write a theory, not practice. You have an interesting object. It's a operator, matrix, or linear function. Doesn't matter. They are the same, more or less. So you are looking for something, a vector multiplied by a matrix, and you got this vector. Okay, this is not perfectly correct. This is an n times n matrix. The vector would have n members. This lambda could be something between 1 and n. So this is not really, this is a there are more values usually. And this is also something n. So xn, error n, lambda, each lambda is a real number you want to fix this equation. Let's start. And now we can stop, because we have to add something. The identity operator, that's n times n, but in the main diagonal there are 1 and everywhere else 0. That sounds better, looks better. Okay, let's looks much better. We can do something at least with it. When is this equation is 0? The trivial solution is when the x vector is a null vector, a 0 vector. But we are do not interested in the trivial solutions. So we have to continue this. This an lambda n an is a linear system of linear equations for lambda. Lambda is called the eigenvalue or eigenvalues. That's better. If you are lucky, there are more. There are more eigenvalues. So, you're looking for this. This equation has solution if the determinant of this matrix is 0. So I can write this in this form. has a meaning of everything. If we want to fix this, we want to get the values. First, we have to find the eigenvalues. When we have the eigenvalues, we substitute back to the original equation, not this one, this one. And then with that eigenvalues, we fix it, and we get vector, eigenvector, or system subspace of eigenvectors. For each eigenvalue has a subspace of eigenvectors. In a normal case, in a normal life, in physics and chemistry, these eigenvectors system has only one member, but this is mathematics, so you will have here subspaces. Is it better than the so yeah, it's I thought the lecture is enough, but it was not enough, even for exercises. Okay. Let's have this matrix. I am looking for the eigenvalues and the eigenvectors and give a basis. Okay, let's jump here. I have this matrix. I have this lambda. Okay, I calculate the determinant. So let's assume I fix the second order equation in my head. So the eigenvalues are these. I do not need to explain for you this equation, I guess. It has two roots, 1 and the 5. So there are two eigenvalues. The now we jump back there. And let's see lambda 1. That's 2 minus 1, 1, 3, 1. So if I do the equation and everything, I got so the solution, the subspace for lambda 1, so what I had done, I took the eigenvalue, put back to the matrix here. I could have write or something like this, doesn't matter. This is the system of linear equation that I got. This is quite general. It's the same. So this is just say the second component is minus 1 times the first component. So it has infinity solution, and this is one. This is a subspace. Okay, I have no more. I have no more board. Unfortunately, I guess you understand this right now. Good. Then here, that's 2 minus 5, 1, 3, 4 minus 5. So this is minus 3, 1, 3, minus 1. So this will be system of following equation. This is something general again. So the subspace lambda 2 will be this is quite general again. And two bases. One basis is and the other but you could give infinite number of bases. It's weird. It's very weird. What is going on? Oh! Great. Great. Good to know. Yes. Okay. So, leave this. The second this is the only difference, but this changes everything. So the only difference in the matrix, that's sign. However, the determinant looks like and this is never 0. So it means this characteristic polynomial has no real solution. This matrix has no real eigenvalue. So we here stop. And jump. The third exercise that looks cruel, but it's quite merciful. The task is the same. Okay, so I have to fix the characteristic polynomial. So, SARS rules. This is 0, this is 0, this is 0, this is 0, this is 0. It should be 0, so there is only one eigenvalue. That's quite nice. I said it's merciful. Okay, we have one eigenvalue, so let's go back to the matrix and fix the equation to get the eigenvectors or vector. So, I can write this is A, and then so I could write here x1, x2, x3, and this should be 0, 0, 0, but you know it. So what we get here is interesting thing, minus, this is nothing here, it's 0, 0. This is minus x1 plus 2x3 again, equal 0, sorry. 3x1 equals 0. So, this means x1 is 0. This means x3 is 1, it's half x1, that's 0. So the solution is something 0, 0, and then something. So the subspace of this is the subspace, this is the eigenvalue, and what else we have to do? Nothing. It's so weird. So when I learned this, the exercises always led to just vectors. So not a set of vectors, and subspace is just one vector. Doesn't matter. Okay. Okay, so the task is the same. It's eigen values, eigen vectors, subspace. So this is what we should determine. Let's start with the characteristic equation. something. That's better.
If you're speaking, sir, we cannot hear you.
Sorry?
Your audio is mute, sir.
Can you hear me? Hello? Did I speak Hungarian? No. No? Okay. Okay, so with blood magic, I recognize this lambda minus 3 in the polynomial, and I convert this to this form. The lambda has two imaginary complex solution and one real, and that's lambda 3. So this is the only rational solution. And then I have the matrix, and that's 3 minus 3, 1, 1, 0, minus 3, 3, 3, 0, minus 3. That's 0, 1, minus 1, 0, minus 3, 3, 3, 0, 3. Okay. So the equations look like, system of equations look like So what I got from this equation, there are infinite number of solution, and the all component of the vector is the same. So the subspace of this eigenvalue this is for the lambda, I mean the eigenvalue 3.
Professor,
Yes?
you are muted from the start of the class in the Teams.
Sorry?
You are muted.
I muted them. Okay, this is what they try to tell me.
Yeah.
But,
Visualize.
okay, I don't know why. Okay, let's see what is the problem. Okay, can you hear me right now?
Yes.
Great, sorry. I don't know what happened. How long have you not been hearing me? Minutes? Hours?
The whole time, I think.
All time?
Yes.
Oh.
I just checked the Teams chat.
I checked actually with this, and then they told me, okay, they're fine. And then perhaps I switched on this OBS Studio, and it took the, what is the name, the mic. I don't know. Sorry. Yeah, it's not easy. At least you are here. Yeah. Before the COVID, I worked for the European Space Agency, and we had the same meetings. Huge room, conference. We had the mic, and then we should have followed the conference because it was cheaper. One guy traveled there, the other 5 listened for the phone. It was WebEx and later Skype for Business. However, the guys always forget we are there. There was one mic. They went to the other corner of the room, talk, and we didn't understand anything. And this was worse than don't sleep or being drunk or something like this, to listen and try to understand, try to following the conversation in this way. So sorry everyone, everything will, in the Teams, the record is bad, then great, I'm happy, I mean sarcastic. But the OBS Studio perhaps recorded everything. But it's almost useless because you cannot see what I'm calculating. Don't worry, tomorrow we will do similar exercises. Yeah, okay. Um, bad. Okay, so. Okay, let's So we have to fix this. Solve, sorry, not fix. Well, we all have some X ability. Mine is speaking Hungarian first. The second, I can fix third order equations in by heart. Actually, not really. I just look at the solutions, and one solution is this. One will be -4, one will be +5. So for the eigenvalues, there will be 3 eigenvalues. One is +1, 2 is -4, 3 is +5. Actually, if you have special ability, you can see it in this polynomial. Actually, I just saw this lambda -1. Okay, how much time we have? 3 minutes. It's quite a nightmare. From this, you get 0, 0, 0, 3, -3. Okay. Okay, because tomorrow at noon we will see each other in this room. I stop it here and continue tomorrow from here. Yeah, thank you for coming. Thank you for your sacrifice. For the team, for the group, class. Okay, I stop recordings. The class is dismissed. Thank you for coming. I will continue from tomorrow from here.